If it's a more specific question, they can help you in one of the breakout rooms that we have.
I'm super excited to teach you guys some R. Hopefully you all, like Reza mentioned, have access to the Slack and the Google Doc. So if you'd like, in the Google Doc, there's a section on sort of the bottom of page 2 where you can give yourself a little introduction, which would be great. And you can also see on there our schedule. So I'm going to start you guys off with going through a bit of intro on R and Rstudio. And then I'll pass things over to Yuka, who's going to cover data wrangling and manipulation with dplyr. And finally, we're gonna have a break in there, and then we're gonna end off by I'm gonna go through some ggplot stuff. So by the end of tonight, we're gonna have you guys making great publication quality figures. Here is the goal. So just before I get kind of into the teaching side, I'll start with just a very brief introduction. Again, my name is Travis. I'm a bioinformatics technician or researcher at one of the research labs at UBC. So I've been working there for about 2.5 years now, and been teaching R for almost as long, maybe like 2 years. Originally started at the UBC R study group, and then kind of got involved into the teaching side of things through that. Yeah, I use R like every day, like 99% of the time, probably. It's really great if you're doing like data analysis and making figures and that kind of stuff. So I really like it, and hopefully by the end of tonight, you guys will share a similar opinion. With that, I'll maybe pass things off to Yuka if you just want to give a brief introduction.
Yeah, thanks, Trevor. Hey, my name is Yuka. I am a PhD student in the MAR lab at the Genome Sciences Center at BC Cancer. And like Trevor, I'm mainly using R for my work, and I've been teaching actually. I'm teaching with 2 different organizations, well, now 3 with Our Ladies. But I've been certified as a software carpentries instructor and as well as a Rstudio instructor, teaching basic and introductory R workshops as well as advanced R workshops since 2016, I think. So it's been a little while. And outside of research, this is something that I really enjoy doing, introducing people to programming so they can, do some more with their work or even just as a hobby. I guess before we get started, if you haven't already introduced yourself, please do on the Google Docs. It's designed to be a little funny so that, we can all get to know each other on a surface level. I know it's kind of hard to do virtually, but, for example, like I'm really interested in the weird bean curd that Lavinia made, and and that's really funny there. And yeah, so go ahead and introduce yourself. And let me just share a couple things in my introduction. So in 3 words, like what do I do? So in 3 words, it would be personalized cancer genomics. That's my jam on a normal day. And otherwise, it would be teaching. And in terms of the last thing I cooked, I'm actually quite excited that I made this yesterday. It was a glazed pork belly. And I don't eat much red meat, but it was like my special day for it. So it was a very exciting day for me yesterday. Yeah, go ahead and introduce yourself there. And also remember, there's a comfort level at the bottom. So indicate A, B, C, or D, how comfortable you are. So it'll help us gauge how much background we should add to our content. And Travis, one more thing. I guess we should mention the code of conduct for Datajam. There is a code of conduct. There's a link to it in the Google Docs at the top page, I believe. And we also have links to the workshop lessons that we'll be teaching. So everything that we're teaching today is online. So in the future, you can go back to it, or even tomorrow when you're in your Datajam sessions, you have the ability to go back, and they're at the bottom of page 1. Those links under lesson 1, 2, and 3. And with the code of conduct, if there's anything you'd like to report, you can obviously, if it's something about me, please feel free to go to Travis or the helpers. And I think they're also designated Datajam auditors. I don't know what the term is, but they're designated people, I think, who introduce themselves. Oh, there's a code of conduct channel on Slack. So please remember that if anything comes up. And with that, I guess I have one last thing, is that if you are not adverse to being recorded, we would really like to encourage you guys to turn your videos on so that Travis and I aren't teaching to blank screens. It is online and it's hard, and we really like seeing your faces, so it makes it feel a little more normal or non-COVID as possible. Yeah, so with that, Travis, feel free to take it away.
All right, thank you so much, Yuka. It's a great intro, and the pork belly sounded actually incredible. I'm very jealous. So I am going to try to share my screen here so we can get started. Oh, okay, share. Is this working? Aha, okay, so hopefully everyone can see this Datajam 2020 lesson number 1. So yeah, again, one more time, welcome everyone. We're going to be going through, to start off, just some kind of intro stuff for R in Rstudio for those who are maybe unfamiliar, or maybe you've played around with it once before in the past, but it's been, a couple of years or something like that. So we're going to go through a little bit of background. Hopefully you are all able to get R and Rstudio installed, and the packages as well. So if you were having trouble, now would be a great time to post in the Slack channel and let one of our helpers know. And then if needed, they can go out into a breakout session with you guys and help you get set up. But hopefully we are all set and ready to learn about some R. So yeah, so we're going to start with a bit of background. And you might be wondering, if you're new to R, why you downloaded these two things, R and Rstudio, what's the difference? So one way of looking at it, nice little analogy here, is to think of it as R being like the engine of your car, whereas Rstudio is like the dashboard. So R is the programming language that is going to run all of your code and perform all your computations and your great models and everything. And then Rstudio is the integrated development environment, or IDE. And this provides like a nice interface for us to use the programming language that's kind of lying underneath. So, obviously you don't get in your car and drive every day by opening the hood and messing around with the engine. You just climb in and take a seat, your nice, comfy, super fancy looking car here, and you're off and away. So yeah, so this is why we have these two things to download. So make sure for today that you're going to be using Rstudio, this little circle with R inside of it. That's what I'm going to be using. It's what Yuka will be using for all of the teaching today. So yeah, that's where you want to be if you're not already. And then I'm going to go through this kind of interactively with you guys, but I'll start off just by kind of scrolling through this little lesson here. So inside of Rstudio, you're going to have a console, which is probably going to be the dominant part of your screen here. You're going to have in the upper right this kind of environment section, and then a files and some other stuff down there as well. So this is kind of your basic Rstudio setup. We're going to be kind of tweaking this just a little bit. And then again, this is where we're going to be spending most of our time today. Most of the lessons for today are all going to be kind of live coding stuff. So we're going to be coding right along with you guys, which is really great. And I'm sure I will make typos and little mistakes because they always happens during these workshops, but that's fine. It's all part of the coding process, as anyone can tell you. And the next big thing are the R packages. So again, these were something that we had you guys install before the workshop. I think there was 3, if I recall correctly: Tidyverse, Gapminder, and CorePlot. So the Tidyverse is actually a collection of a bunch of different packages, but they all kind of come bundled in this one called Tidyverse, which is really great. Gapminder is actually some data that we're going to be using. So this way you can kind of install the data or load the data as an R package, which means you don't have to worry about trying to like read files into Rstudio or anything. So that's going to streamline our session a little bit. And core plot we'll get into later is going to allow us to make some heat maps towards the end of the plotting section. So one way of kind of thinking about these R packages are sort of like apps on your phone. So you can you'll be getting apps from CRAN, which is where you got them from for today. So that's the install.packages command. But you can also get packages from places like Bioconductor, which is where if you work with biological data like RNA-seq or microarrays or epigenetics or anything like that, you are probably going to be downloading some packages from Bioconductor. We won't specifically cover those today, but just be aware that that does exist. And you can even install, it's not listed here, but you can also grab packages straight off of GitHub, which is really nice. So there's a kind of a couple steps involved when you are using a new package, especially. So installing the packages is like going to the Play Store or the App Store on your phone and like downloading that app. And then if you actually want to run that app, you have to, on your phone, you like click to open or whatever. And it's a very similar process with Rstudio. So you install the package with install.packages, and then you kind of load or open the package with another command, which is the library command. So again, we're gonna go through examples of all this stuff. So don't worry about it too much right now. But yeah, so there's a kind of 2 steps you need to do. Install packages, which you should only have to do once. So once those files are downloaded, they're on your computer and you're good to go. And then loading or opening the package with library is something you'll need to do anytime you close and then reopen Rstudio. You'll need to do library tidyverse or library gapminder to get those packages loaded in. So keep that in mind. There's some further reading here, but we're going to move right along to talking about Workspace and these .r data files. So the whole idea here is when you're loading data into R and working with data in R, you're going to create kind of objects within R. But when you close Rstudio, those objects are going to kind of get lost. And it's really important to kind of think about these things, especially when you're setting up kind of larger projects. And it's important to know kind of where your scripts and your data and everything lives on your computer and how Rstudio kind of accesses that. So one of the ways to do this is by looking at where your working directory is, which is going to kind of have a default location on your computer when you open Rstudio. So I'm actually going to switch over to Rstudio here. So you should be seeing my Rstudio setup. So we can go into the console here and type like get wd. And I'll just mention briefly, when you have this kind of autocomplete, you can use either the mouse cursor or the arrows to kind of look at the different options. And then enter or tab will kind of complete and fill it out when you've highlighted the one you want.
Hey, Travis.
Yeah.
Hey, Travis. There is like a WebEx icon to the very left of your screen. I don't know if you can see it as well. It's like it's blocking your code.
Oh.
You think you could? Does other people see this too?
One other thing with WebEx is there is a way I think that everyone can you're supposed to be able to zoom in and out for yourself. So on the side of the window, on the left-hand side there's a little bar where the screen is shared where you can zoom in and out and move make you can move the window in and out. So I think for me it was fine.
Okay.
It wasn't blocking that the code. So maybe like Yuka, you might need to zoom in or out on your side, and anyone else who has the same issue can zoom in, or if a font is too small, you can zoom in as well.
Okay, zooming out worked for me. Thanks.
Okay.
Did that work out?
It worked for me too.
Okay, perfect.
Okay, great. Thank you guys for letting me know. That's weird. I can't see anything on my screen, so it must just be because you're like viewing my shared screen. So hopefully, if at any point like something's blocking what I'm typing, please just someone interrupt and let me know, and we can shift things around. So just to get kind of back to where we were. So if you want to look at my working directory, excuse me, You can see for me, it's, C, users, Travis, Blimkie, documents, whatever. And if you run this on your own RStudio, you'll get, something probably a little bit different. If you're on Windows, it's going to look probably fairly similar. If you're on Mac or Linux, it's probably going to look a bit different. But this is where R is kind of by default going to look for files. Like if you were trying to load data into RStudio, this is the first place it's going to be looking for, which can be problematic if your data lives in like another folder, maybe like a subdirectory of documents you have set up for your project. So being kind of just aware of your working directory is important, because it will probably at some point cause you some issues. There are kind of ways to get around it, and there are ways to change your working directory. So there's another package called here, which is built to kind of as a sort of alternative to using the next command we're going to talk about, which is set working directory, which is how you change your working directory. So here is meant to be like a little bit easier and simpler to use, but it's not going to be a huge issue for today. We're going to be just kind of loading data in from this gapminder package. But Jenny Bryan, who is like a big R and RStudio person who does all sorts of teaching and development at RStudio, does not like the use of setwd and will in fact try to come to your office and burn your computer down. So I would recommend against using that one as much as possible. So if you do run into problems, try using here. And the kind of main issue is that if you have a script and you're using the setwd command to change your working directory, and then you send that script to someone else, their computer is not going to have the same structure of files and folders that yours does. And so this code is not going to work on pretty much anyone's computer except your own. And if you move things around, then it's not even going to work on your own computer anymore. So yeah, definitely best to try and avoid the whole working directories thing. Another alternative, which is kind of the way that I tend to run things for my own work, is to use projects. And then wherever that kind of project is based, that becomes your new working directory. And then you just have separate projects for separate work that you're doing. So yeah, and then it's also important when you're working on bigger projects, like if you're doing a PhD or anything like that, to keep your data really well organized. So typically this is how I kind of set my project folders up, is to have one spot for kind of all of my raw data, which you kind of just put there to use, but you don't edit, you don't change it in any way. You always want to preserve your original data. Another spot for any kind of process data, so kind of more downstream things coming from your raw data. Another spot for your outputs, figures, plots, anything like that. And then finally, somewhere to keep all of your scripts. So it's, yeah, just things to kind of keep in mind. Again, we're going to spend more time on sort of the nitty-gritty coding side of things today, get you guys up and running. But these are things to kind of keep in the back of your mind as you go forward. And if you start using R more and more, these are things that are going to become more important as you kind of go along. So with that, I'm going to switch back to RStudio here. And we're going to go through a couple kind of interactive things, and I'm going to point some stuff out to you. So the first thing we're going to do is actually go up into the Tools menu at the top. So again, if anyone can't see what I'm doing, just please let me know. So the Tools at the top, which will give you a nice little drop down. And if you go down into Global Options, so that's Tools from the top and then Global Options. And there's a whole bunch of settings in here. Some of yours might look a little bit different than mine right now, but that's okay. It's not going to cause too many problems for us today. So the one we want to look at is Pane Layout. So on the left-hand side, there's that list of a bunch of options. So
Travis, sorry, can I just interrupt for just one sec?
Yeah, of course.
If someone's using a Mac, it's going to be under their preferences.
Okay, awesome. Thank you. So yeah, Tools, Options on Windows, Preferences if you're on Mac. If you're on Linux, I'm not sure what that would look like. I think it's still Tools, Options, if I remember correctly, but hopefully you guys can all find your way here. This is not super essential for today if you can't, but it's going to kind of streamline things and make, if you do run into problems down the line, it'll kind of help our helpers essentially. So what we're going to want to do is change these up a little bit. So this is currently controlling kind of the layout of our RStudio. So we're just going to make, I think, 2 basically changes. And Yuka, you can correct me here if I have mixed these up, but I think we're going to want, in the top right portion, we're going to want to change this to be console.
Yeah.
So now we got source and console along the top, and actually it changed automatically. So now we have the environment history, etc., bottom left, and files, plots, and packages on the bottom right. So again, that's source.
I think you're frozen there. Your screen.
Oh.
Now it moved. Never mind.
Okay, no problem. Hopefully that doesn't keep happening. Oh, it's very laggy. Okay. Don't know what I can do about that, unfortunately. Yes, thank you. I might be able to switch to an Ethernet for the next section, but I think for now I'll just try and push on here. But so yeah, source in the top left, console top right, and then environment bottom left, and files, plots, etc. on the bottom right. So once you've done that, you can just hit OK. And your RStudio layout is going to probably change quite a bit. I'm just going to kind of resize things here, so hopefully you guys can see this okay. Do that. Oops, no, don't leave the meeting. Definitely don't leave the meeting. Oh, that doesn't work. No. Okay. Okay, so now that we're into RStudio, and you all should be looking at the same thing. Okay, that doesn't work. So in the top left here, we have what was called the source window. So these are where we're going to create our scripts. It is, isn't it? So the scripts are really great because they allow you to actually save your code and rerun it later, or send it to a friend or a coworker. Whereas the console, which is on the right-hand side here, you can type something in. So I could do like 5 + 2. And great, it's 7, but there's no way to kind of easily save this information if you're doing, a whole bunch of different steps. So again, the console is kind of more interactive. You can use it if you're trying to maybe just like test things out or figure something out, but anything kind of more advanced, or I don't know, more, what's the word I'm looking for? More kind of like hands-on and kind of like longer, especially, you're going to want to prefer to use the script section, or the script or source window. So you can write, like for example, library tidyverse, and then, I don't know, you can do glimpse. And don't worry, we're going to go through some more of these commands later. Glimpse, mtcars. I don't actually know if this will work right off the bat, but we'll see. And then, so another thing I should mention, if you want to, so you type this code, but it doesn't actually run right away, because we're working in a script file. So to actually run like a line of code, you can highlight it and then click the run button here. So I'll kind of hover my cursor here for a second. So highlight the code you want to run and then click the run button. You can also just click Control Enter, which is the shortcut for run, or Command Enter if you're on a Mac. And that will do the same thing. It'll run that highlighted code. So again, we've now run library tidyverse. So this is loaded that package that you guys all installed. And you'll get a bunch of output and probably some conflicts, but we're not going to worry too much about those for today. And then the other thing we're running is this glimpse and mtcars. So this is actually like a data set that comes kind of bundled with R and RStudio that allows you to kind of run simple tests and stuff like that. So if we run this glimpse mtcars, so again, that's Control or Command Enter. You can see now in our console, and I'll make this a little bit bigger. By the way, is my font size okay? Can everyone like read this on their screens suitably? Yes, I'm not getting any.
Yeah, I can see it.
Okay, great. Let me know if it is too small, and I can adjust it.
Yeah, and as I mentioned, there's that little button on the left side that everyone can zoom in and out as well for themselves. So
yeah, perfect.
That also works very nicely.
Yeah, so you can see this is kind of the 11 columns of our data, MPG, cylinder, displacement, et cetera, and then a bunch of the values. So yeah, we're going to want to prefer writing code, especially for today and probably going forward for you guys, to write in the source script window, and then you can save it. So you can go File, or it might be, I don't know, on Mac, it might be a little different. but you can go File, Save, and then I'll just save this as like intro. And then for any of your scripts, you're always going to want to save them as like a .r, .R, so that way your computer will know that those are R scripts and not something else. So again, that's just Control S or File and Save, and then save it as, you can name it whatever you want. You're probably going to just be working off one script for the whole of today, so you can name it, workshop.r, something like that. And we're going to click Save, so that's done. And then a couple other things. Oh, there it is. A couple other things that I will mention here before I pass things off to Yuka. The first one is going to be kind of object assignment. So like I was doing earlier, you can type directly into the console and run whatever you want. That's great. Oh, that's not okay. But sometimes you're going to want to like save the output of different commands so that you can do something with that later. So the way you do that in R is with the assignment operator. So it's a really simple example. We can do like, you want to assign something to X, so we do X, and then it's less than dash. And then, so let's just make X 5, let's say. So again, that's for assignment, you do like the name of whatever the object or variable you want it to be, and then less than and dash to insert the less than, and then the dash sign, and then whatever you want to assign to that object. And again, if you highlight and then Control Enter to run this code, now you can see down at the bottom here in the environment pane, we have our X, which is equal to 5. And if I go over to the console here and type just X and then Enter, you can see that now it says, X is 5, and I can do X plus 5. And, the answer is 10, which is, of course, what we would expect. So this is something I think Yuka will probably be using primarily as opposed to myself for the ggplot section. But this is, again, something that is going to come up a lot when you're writing code with R. And then the final thing I want to mention is, let's say you're trying to use some.
Can I add one thing, Trevor?
Yeah, of course.
Travis, sorry. Oh my God, sorry, Travis. So one thing to mention is the assignment operator, which is less than and the dash. It's very specific to R. And if you're coming from a different language, you might be more familiar with just the equal sign. And that actually does work in R as well. But there are instances that could cause some problems, very, very limited, rare occasions. And if you get into the habit of using this assignment operator, the arrow, you will be able to avoid those potential problems down the line.
Yeah.
But if you were to prefer, you're used to Python or a different language, you just want to use the equal sign, like feel free. But I will be mainly using this assignment operator on the screen right now.
Yeah, great. Thank you. Actually, I'll also mention there is like a keyboard shortcut for this. So on Windows, it's Alt and then like the dash or minus will insert the less than dash. So we can do another one here, Y and then Alt and then dash will insert the whole thing. And then we can say, Y is equal to 10 and highlight and run that code. And great, we're all set. Awesome. So the one kind of last big thing, or it's a couple more things, I guess, but one thing I'll mention is if you're looking for help on any, on any functions inside of Rstudio, there is a help pane here, and then you can, search here for like glimpse was one we were just looking at. Oh wait, sorry, it's up here, wrong spot. So in the top kind of right of this help pane here in the bottom, there's a little search. And you can type in and search for a function that will run. Is it not running? Hey, it just was slow. There we go. So you can see it's listed a couple pages. The one we're going to look at here, just as an example, is this glimpse. And then make this a little bigger here. So it'll give you the usage and then all of the different arguments that the function takes. And then the especially useful section for me is this examples section, where it will actually give you examples of how the function is used. So this can be really helpful if you're running into trouble. And you can also search for help right from the console. So if you type question mark glimpse, for example, you can see it's already kind of, thinking about what I'm gonna want, so you can do it that way. And then if you don't know the specific name of something, you can do 2 question marks and then the same glimpse, which will do a sort of more kind of general search for your term. So again, there's the help pane you can access directly. And then from the console, either 1 or 2 question marks will allow you to search through all of the help pages that come with Rstudio and any packages that you have installed. Okay, and then just 2 more things to quickly mention before I pass things along. So one is if you're looking for help outside of Rstudio, if you're kind of new to coding, you may not be familiar, but there's a few websites I'll mention where you can go for help. So Stack Overflow is one of the big ones that anyone who's coded in any language is probably familiar with. So if you just Google, Rstudio, how do I do X, you'll probably find a post by someone who's had the same problem and hopefully an explanation. BioStars is one if you're looking for more kind of help questions specific to kind of biological data. That one's really useful. Also, if you are using something that's on GitHub, you can definitely check the issues on GitHub. You can search, old issues and that kind of stuff, and you may find something there. But definitely, just in general, Google is definitely your friend. Just Rstudio and whatever your problem is, and you'll be able to find some help. And the last thing I will mention there's cheat sheets for Rstudio. So I'm going to switch back to my browser here and go Rstudio cheat sheets, and you can Google this yourself and check it out. So these are kind of like nice little PDF documents that kind of summarize how to do all sorts of different things in Rstudio. So there's deep learning if that's what you're into, working with strings, what else? Importing data, data transformation, which is actually kind of some of the stuff that Yuka will be covering today. R Markdown's another great one for kind of making really nice reports. There's one for kind of Rstudio itself and how to kind of set it up and edit. Shiny is another good one for developing web apps. So yeah, I won't go through any more, but just know that there's some cheat sheets available, especially for the topics we're covering today. And maybe while Yuka is talking, I will post those in the Slack group for you guys. But they're nice, really little references for oh, how do I do this thing? I don't quite remember. And then you can check the cheat sheets and find out how to do what you're trying to do. So I believe, Yuka, I think I got everything, but yeah, otherwise I'll pass it along to you for your section and we'll keep on going here.
Awesome, thanks. There is a R help channel on Slack as well. There is a link to those cheat sheets, and there's a few YouTube videos that I guess are to help you with R. I haven't watched them yet, but I'm sure they're helpful. So feel free to look through the Slack channels. There's some really fun stuff, and there's a jokes page, so that's there too.
Yeah.
Okay.
Can I just add? Yeah. So tomorrow I think we'll be monitoring this Slack channel quite a bit. So if there's any point that you're coding and you are stuck with anything, feel free to just send us a message on there and say, hey, I'm stuck with this, and we can help you out.
Cool. Thank you.
Okay, I'm going to stop sharing.
Before I move on, I just want to ask if anyone has any questions. This would be a really great time to ask Travis some questions while I set up here.
Again, I have the Slack open here if you want to post a question there. You can post it in the Cisco chat, though, again, we do prefer the Slack if you can. But yeah, let us know if you have any questions. Hopefully our helpers here, they're here to help you guys out as you would expect. So please just let us know if you run into a problem or just even have a general question. We love those because, if you have one question, probably someone else has the same one. So definitely ask away.
Yeah, and maybe right now, because we're in a bit of transition period, just feel free to unmute yourself and ask your question if you have one.
Okay, I'm going to take this silence as a good sign. I can't see anyone's faces just because of my screen real estate. So feel free to chime in at any point. So what I'm going to cover in this section is a package called dplyr. So up here it says Intro to dplyr. So dplyr is a package that's within the tidyverse package that you actually downloaded. So it's kind of encompassed in tidyverse. And dplyr is a data wrangling tool. So I have this cute cartoon here by Alison Horst, and I actually have it as my virtual background as well. So basically what dplyr does, like a pair of pliers, it helps you, manipulate your data, and you can wrangle these messy data that you have. I'm seeing some questions. I can look at that in a second. So anyways, so the form of data that comes in, like you might have very clean data, you might have really messy data, but at the end of the day, what we spend a lot of time on is data wrangling as data scientists. So we thought it was really important that we start with this and spend a lot of time on data wrangling as a part of this workshop. And I will note, so I'm a software carpentry instructor, so I will plug this in, that a lot of this material is from the carpentry's website. So they have a bunch of our 2-day workshop contents that are available online, and it's free to distribute. And so feel free to check those out as well, and it's linked there. What I'll be covering today is a very small portion of the software carpentry workshop, and mainly I'll focus on these 8 functions. So glimpse is something that you saw with Travis. We'll also be using select to identify columns and all those below. And I'm not going to name them because we're going to work with them as we go. Okay. So while I'll just switch over to my Rstudio here. Give me 1 second. Okay, so I'm seeing some R version comments here, so I will share with you what my version is. So if you type, so before I start, can everyone see my screen and the text on my screen as well?
Yep.
Yeah. Okay. So if you type version in the console, you can see what version of R you have on Rstudio. Currently, I don't think this is the latest one, but this was one of the major updates to R 4.0 that I was really excited to download earlier this year. And each version comes with a funny name, Arbor Day. It has something to do with the Snoopy comics, but I'm not really in on the inside jokes, so I can't tell you more beyond it, but that's kind of a fun nugget you can look on the internet for. Okay, so before we start, I'm just going to reorient you to the screen here. So everyone should have this page, these 4 panes, and maybe they're blank, maybe they're not, but we can, if you want to start a fresh page, you can click on this logo on your top left corner, and you can click our script, which will open this brand new script page where you can start taking notes and also following along with what I'm doing. And, okay. So one thing we'll do, if you haven't already, is to install packages. If you've already installed them, feel free to skip this step. So I'm going to install packages here. And I'll note here, the hash symbol or the sharp symbol indicates a comment. So this won't run as a code. It's just kind of text for me to take notes on what I'm doing. So install packages. I'll use tab to complete that code there. And I will install the 2. So tidy first, and double quotes, comma, and Gapminder. So this, if you run it, if you highlight this text and you hit Command Enter or Control Enter if you're on a PC, I think. I don't know. I'm on a Mac, guys. If you hit Command Enter, you should start, your RStudio should start installing these packages. And if you already have them installed, we want to load the packages that we have. So in order to load, you want to open up your library. So type library, open parentheses, tidyverse, and hit Command Enter. You should see on your right-hand side that the code is running. So I'm just going to move this up here so you guys can see. And then we'll also load our library or Gapminder. And note here that I don't encompass this in double quotes. So just keep that in mind. This is kind of like an object. It's a special thing. I just have to remember that with packages that are already downloaded, you can just use the text without the double quotes. So I know this way, once I've entered these two things, my library is loaded. But another way to do this, if you want to use the full function of RStudio, is to come down here and select packages on the bottom right pane. And you can scroll here and look for the packages that you want. So I already have dplyr checked. And by having it checked, it means it's loaded, this package, and you can kind of keep scrolling and find what you want as well. So there's an interactive way of loading packages, which RStudio makes it really easy to do. Okay, so tidyverse, this package here is what we have. That's where all our tools and functions will come from. R itself, the basic function of R or base R has their own way of manipulating data. But for both Travis and I, we thought it would be easier if we introduce you to what's commonly used nowadays called tidyverse. And the grammar around tidyverse is much more intuitive, and it's almost like you're reading text. So I find it really useful to introduce people to tidyverse first before we even talk about base R. And in this workshop, because it's so short, we're actually not going to cover any base R, unfortunately, but just something to keep in mind. And this library for Gapminder, it's kind of a cheat for us because we didn't want to deal with loading data for today. So we're just grabbing our data called Gapminder. And because we're using this open source Gapminder, I feel inclined to introduce what Gapminder is. So Gapminder data is from the Gapminder Foundation, which is a nonprofit from Stockholm, Sweden, and it promotes sustainable global development and the achievements that the United Nations Millennium Development Goals were trying to achieve, which is to increase the use and understanding of statistics and other information about social, economic, and environmental development at both the local and national levels. So we thought we'd use some social science data today that I think everyone can relate to at some level. Okay, so that's my spiel about data. So we'll start with introducing you to Glimpse. So Glimpse is a function that Travis earlier showed you, but let me talk about what Glimpse actually does at a little deeper level. So let's just follow me and type Glimpse Gapminder. So if you have Gapminder loaded, you should see something pop up on your console here. So what Glimpse does is it gives you a glimpse of your data. It's pretty intuitive if if you speak English here. So you can see that it's telling you that this data Gapminder has 1,700 rows, 6 columns, and it tells you exactly what those columns are. So it's country, continent, year, life expectancy, population, and GDP per capita. And this is the social science data that we downloaded from Gapminder. And in addition to that, we can see what data types we have in our data frame. So in this data frame, we have factors, integers, and doubles. So we can just kind of ignore the differences between integers and doubles and just think of them as like a numerical value. Factors are special, and we will just say for now that they are just categories of text. So for example, if you have Afghanistan multiple times, you can think of factors as being smart enough to understand that each of these entries come from one single country value, which is Afghanistan. That might be a little confusing, but as we work with it, I think we won't run into any factor-based issues. But that's something to keep in mind, that factors is its own unique form of categorizing text. There is another value called characters, which should come up as CHR, which is distinct from factors. But Glimpse just gives you a quick understanding of what you're about to work with and what kind of data types that you have. So this is something that should be done at the very beginning of your data manipulation journey, I guess. Okay.
Sorry, just to pipe in super quick.
Mm-hmm.
So yeah, just a couple things, I guess. One is for the character stuff, if you're coming from like Python or another language, these are kind of just like strings. So they're just like, typically they're going to be, numbers or words. So those are probably going to be, for the purpose of this lesson, like more common than factors, which again are kind of weird at first. So we're not going to spend too much time on those. Maybe at the break or something, or at the end, we can talk about that a little bit more. The other thing I will mention, just to kind of go back a bit towards the start of Yuka's lesson with the comments, I would just like to mention it's very important that you guys comment your code really well. And it's more about kind of explaining like what or why you're running your code as opposed to simply what the code is. But it's really important to like comment your code well, because you might think when you're writing it that something is obvious, but in a few months or a year from now when you go back, it's not going to be quite so clear. So please comment your code consistently and thoroughly and all that, because it'll save you headaches in the long run. But anyway, that's all from me for now.
Awesome, thanks. Yeah, so comment liberally and like comment for your future self is what I tell everyone. So maybe Glimpse isn't the best comment to make. Maybe you want to say introduction to Glimpse, something like that. Okay. I'm just gonna mention here, because we are not gonna load data that's in a CSV file or whatnot. I have put on the website instructions to how you can load, read and write CSV files as well as other text. So please refer to that tomorrow if you need help with it. And so we're just, we're gonna move on to the next function. But if you wanna cover loading data and writing data, feel free to let me know. We can cover that in the breaks. So the next one is called select. So select is a really nice tool from dplyr, and it lets you select columns. So one thing I'll demonstrate here is because Gapminder has 6 different columns, we can say we want to select 5 of them. So let's create a new variable called Gapminder select. This is just the name that I'm going to use to put my new data frame. So if we say select, open parentheses, Gapminder, comma, country, year, life expectancy. I'm just gonna do that so everyone can still see. And pop for population. And you run this code, you can highlight the whole thing, run it. Oh, there's something wrong here, and the error is telling me life expert doesn't exist, and that's because there's a typo. So I'll erase the R there, and now everything should be running well. So if you don't see any error, that's a good sign. One thing you'll notice is that we don't see the new data frame that we made, and that's because everything that we did on the right-hand side is now being put into a variable on our left-hand side. And if you're really unsure that, I just want to make sure something actually happened, one thing you can do is take a peek below onto the bottom environment tab here, and you can see that Gapminder select was created. So if you actually want to look at what Gapminder select is, you can, again, take a glimpse, open parentheses of Gapminder select, and you should see on your console that you have the four different columns that we selected, which is country, year, life expectancy, and population of Gapminder. And you'll notice that the number of rows maintains the same. So we're just grabbing every row from these 4 columns. Okay. Another way we can write this out is, so with code, we'll propose some challenges, and I'm just going to say there is no one right answer because there's so many different ways you can write code. So let me demonstrate another way we can write this. So Gapminder, let's just call this select2. And this is horrible practice. You want your variable name to mean something to you. So this is bad practice because I don't know what the difference between Gapminder select and Gapminder select2 is. But when you're working with your own data, be kind to yourself and make a variable name that will make sense to you and make sense to you in the future. Okay, so the other way to write this is Gapminder, and it introduces a new function, you could say, called the pipe operator. So it's this percent greater than percent symbol. And you have to write this without spaces in between. It has to be, right next to each other. And it's called a pipe symbol. And what this does is it pushes everything on the left-hand side of the pipe symbol to the right. And so if we say Gapminder, pipe symbol, select, and we can say country, comma, year, comma, oops, comma, life expectancy, and population. I'm just adding an enter here just so everyone can see my screen, but feel free to just, keep it running throughout as well. And so if you do that, you should see at the bottom, you should have the same number of observations or rows and same number of variables, which is indicating columns here. They're using very different names, but that's kind of what information the environment pane can give you. Okay, so hopefully I didn't lose anyone because I'm just going to introduce a third way. So let me just say this is first way of selecting, and this is the second way of, well, it's not just selecting, it's first way of writing code, second way of writing code with pipe operator. Oh, is it an OR? I don't know. I'm a terrible speller. Okay, so third way of writing code, and I'm not gonna explicitly say what yet. So the third way is, so we can let's just copy this over so we don't have to keep typing. We'll call it select3, and it's Gapminder, and we're just going to add a period here and a comma. And we can run that, and it should look exactly the same. Okay, so let me explain to you what this dot is doing here. So this is the period. It's not like one of those floaty dots. What this is doing is it's kind of like a placeholder for what is coming from the left-hand side. So it's saying, so you see the first way of writing it is very explicit. It's telling select to take Gapminder and then take all these 4 columns. And it did it well. And the second way, we took out Gapminder from the select parentheses here and we put it outside of select, and we used a pipe operator to push this data frame in. And it intuitively knew that, okay, if data frame is coming in, I'm gonna select all the columns here. And the third way is with code, you want to be explicit sometimes, because sometimes the order of what you give matters. So for example, let's look at the help menu for select. So if we do !select, you should have the subset columns using their names and types. So this is the help document for select. And if we go down, you can see this usage here. So usage is saying, it's showing select data and then 3 dots. So those 3 dots is indicating whatever you want to select for your columns, but it's showing that data comes first. What if I reverse the order and I gave it all the columns, but not the data? And that may cause an issue. So sometimes we want to explicitly say, here, I am giving you the data right now. And so if you want to be very explicit, the fourth way is to say data equals gapminder. And that should technically give you everything, but no. Oh. All of. It's not working for some reason. Oh, you know what? Because I shouldn't have gapminder out here because it's pushing in 2 data. 2 data. So that should work. Sorry. So if you guys caught what my mistake was, so I had just copied this over and I said data. So I pushed gapminder into a select function and I again told it what data was, and it got really confused because it's now experiencing 2 inputs and it threw an error. So that was my mistake there. So if I remove that, everything should work fine. So these are just 4 variations, and hopefully it didn't confuse you guys. You can just pick one and run with it. I just felt obligated to show you what the ways were so that in the future, if you run into different code, like you know exactly why there are variations between people. Okay, so we're gonna move on to the next section here. Okay, so the next section is actually our first challenge. You can find the challenge on, oh, you know what? I will just scroll. Challenge 1. It says it'll take 5 minutes. It might take less because I see a lot of people are already experienced are users. But what I want you guys to do is to reorder the code below so that you can create a code using select and pipe operator to pick the columns content, GDP per capita, life expectancy, and year from the gapminder dataset, and then assign them to a new variable called result and take a glimpse of that data. So take a look. So it's like if you just want to reshuffle it, and if A comes before C, just write that down. And I want you guys to go to the Google Docs, which there are exercise sections at the bottom. And so once you're done, just put your name under the challenge section once you're done. So I'll do that here just to show you. And so just let me know once you're done. Don't post the answers, just spoil it. So I don't want you guys to spoil it for other people. So just put your name, don't write the answers, and then we'll go over it together once I see that everyone's kind of had a chance to take a look at this.
Awesome. All right. So while you guys do that, if you have any other kind of questions for us, maybe more general questions, feel free to ask them during the couple minutes here while you guys do your challenge question. Type in on the call here, or you can post in Slack as well, whatever suits.
And just imagine elevator music playing right now.
I don't even know. Oh, one thing maybe I will mention briefly. So if you're familiar with coding, like this will probably not be new to you, but if you're newer to the whole coding thing, it'll be useful to point out that R and most programming languages in general are very much case sensitive. So, if Yuka or myself is typing something out and it's lowercase or uppercase, or one letter is uppercase or something like that, do make sure you pay attention to that, because R treats upper and lowercase things totally differently. So if maybe you get an error and you're not sure what's going on, check that you haven't got the case wrong anywhere. That's a common thing even for me still today, so don't worry about it. But yeah, something to kind of be aware of.
Yeah, that's a good point. Thanks. Yeah, coding is a bit tricky if you haven't coded in other languages before, because sometimes, yeah, syntax like capitalizations matter, and then where you start a new line, like if you press enter, like I did before, just to be able to contain all the code within a window. Sometimes that placement is important. I can show you guys when that matters and when that doesn't. Because in some languages it's extremely sensitive. R is not. It's more forgiving. But we'll go over that once I see that everyone's had a chance to go through the challenges. Okay. I see that there are 19 people connected on the Google Doc. So is it safe to assume that the rest of you are still working on this challenge?
I think just based on the people in the call here, we have about 9 participants right now. So
Oh, really? Okay.
I don't know.
Very deceiving.
Oh, I don't know why there's 19 then, because yeah,
Okay, so is this all of us?
14 on the call, and then there's like 5 of us between helpers and instructors. So I don't know.
Okay.
Someone else is just taking a look, I guess. Who knows? I mean, it's interesting
Okay.
stuff. I'll give them that.
Okay. I'm gonna say that maybe we've had enough time. If you want some more time, can you let me know using Slack? Okay. I'm going to assume that we're all ready to move on. I hope you guys don't mind that I pick on some people to kind of say what they think the answer is. And I like, if you feel like it's too much pressure, like feel free to say pass. And, you know, I don't want to put anyone on the spot, but I also want to encourage someone to, you know, if you want to, if you feel comfortable, like please unmute yourself and will you share with us what you think the answer is? Anyone? Okay. Oh, go ahead.
I was going to say results, pipe, gapminder, percent greater than, percent select, consonant, and the rest of it. And then the second line below, glimpse result.
Awesome. Yep, that's exactly it. Thank you so much. Okay, so if you guys heard that, that is so B followed by E, then D, then C, then A, if you were to use the letters. Okay, awesome. Sounds like everyone is on it. So we will move on to using filters. Okay, 1 second here. Okay, back to my Rstudio. So next, we're going to introduce lowercase here, filter. So filter is the next function that we're going to cover. So we've covered select, which selects the columns, but it's also nice if we can, you know, select by row. So that's actually called filtering. So we filter it by the rows. So columns go vertically, rows go horizontally. Okay. And here, okay. So let's start a filter on a specific country, and we'll use Canada since we're here. So we're going to assign it to a new variable called gapminder_Canada. And yeah, gapminder, gapminder, pipe operator, and then enter, and filter, open parentheses, country, double equal sign, whoops, Canada. Okay. So there are a few new things here. One thing I mentioned earlier while everyone's, you know, doing the challenge was enter the placement of your enter is important sometimes. So here you saw me put an enter after the commas, which distinguishes all the different columns I'm selecting. Here, I just want you guys to know that where the enter symbol goes matters if you have a pipe operator at the end. So if I were to press enter here, that would break my code. So I'll show you something that won't work. So something like this shouldn't work. So it looks like it worked, but if you take a look at my console, what it's doing is gapminder is just being assigned to Canada. It doesn't know that there's a pipe operator in the next line. So what we need to do is we always need to make sure that the pipe operator is always, it always ends, or at least encompasses the previous line that you intend to pipe. So if you place an enter after the pipe symbol, that should work. So we say, we run that. We take a peek on the right side here on the console, and we see that our whole code is being written now. So that's a good sign. And so we should take a glimpse at what we have. So glimpse, Canada. Oh, the other new thing, I'm so sorry, is the double equal sign here. So it's not a single equal sign. That's a different thing. So that's like an assignment operator, right? Like I mentioned earlier. A double equal sign means equals. It's a logic saying find everything that looks like this, which is Canada, in my column country. So when you take a glimpse of your data, you should see that the data frame is reduced so much more than it used to be before, because before we had like 1,700 rows, right? Now we only have 12. So it means that we have 12 entries for our specified country, which is Canada, and we still have all 6 rows that we used to have in our original data frame. So this type of equal sign is it's a query, but it just means that filter everything that equals this. And this type of query, so what we're using here is logic. So if you want to combine like ors and ands, these are logics, so you can make them conditioned on different values that you're interested in. They may come really useful for you as you are coding for your Datajam tomorrow. These are the types of manipulations that might come in handy for tomorrow. Okay, so the other logic, so I'm going to comment here. So you can comment in a new line, but you can also comment at the end of your code. So double equal sign for this means matches or equal to. So that's one way you can comment. Just make sure that you don't put the comment in front of your code, because that would just make everything a comment and it won't. So you can put it at the end. You can even put it, you can put this up here too, and that would work. It'll just interpret everything behind it as comment. Okay, so the next thing we can do is, for example, we have a bunch of life expectancies that we can filter on. So gapminder underscore life expectancy, or LE, and we're going to assign a specific subset of gapminder. This time we're going to filter on, life expectancy that's greater than 50. So this is another logical operator. It's asking the filter function to look for anything above 50. So it's not greater than or equal to. So if you want a greater than or equal to, it would be this, greater than or equal to. You also have less than or equal to. These are logical queries that you can make. So we can run this code here and take a glimpse. We'll do that below. And if you look on your right-hand side, you should see all the life expectancies that are above 50. That's a good thing, right? So there's lots of countries from multiple years that have life expectancy of 50. That's great. Humanity is doing well. The other thing is you can combine filter. Wrong place. So you can combine. Oh no, come back. Combine filters. So you can combine different conditions. So we can combine conditions to filter on. So for example, we're filtering on life expectancy and also by country, so we can combine the two. So let's assign that to Gapminder, Canada, life expectancy, and it's Gapminder pipe symbol, as we did before, filter. And the first thing we did was we filtered by country, which equals Canada. And we can put comma here. In addition to filtering by country, we can filter by life expectancy greater than 50 and run this code here. And again, we can take a glimpse. Gapminder, Canada, life expectancy. And oh, this doesn't mean that no Canadians lived beyond 50 years of age. It's an error in my code. I spelled Canada wrong, if you can see here. And so if things aren't working as you expect them to, because you will have some basic understanding of your data, make sure you do some sanity checks, because if that happens, don't assume that the data is wrong. Just take a look, and it's mostly, 99% of my mistakes are typos. And I have a feeling that's the case for a lot of people as well. So keep an eye out for typos. I may not be the best person to look at my own code. A lot of times, if someone else is looking at my code, they can pick out my spelling mistakes a lot quicker. So use your friends too. Anyways, so we picked out everything above 50. So these are ways you can combine conditions. Okay, so we move on to our next challenge. And that is also on the website here. We will go to challenge number 2. So take a few minutes and read this. And basically, you're picking the right answer or answers that will give you this output. So basically, use the filter function to choose data from all the African countries from the years 1982 onwards, and assign them to a variable called Gapminder Africa. And the hint is use the greater than or equal to symbol, or that is the greater than or equal to symbol. I'm not going to tell you to use it, but it's just there as a hint. So look at the different options here. You have A, B, C, and D. Which of these code will satisfy the question? And not only can you identify, if you can identify the right answers or answer, great. But if you can also explain why certain answers don't work or why certain options don't work, that's even more of a plus. So if you finish really quickly, just think about why certain things don't work as well. And again, when you're done, put your name on the Google Doc so we can keep track. Okay.
All right, thanks, Yuka. Again, if you guys have questions, feel free to either post them in the Slack, or if you would like to kind of chime in on the call here, if you have a more kind of general question, by all means, feel free to do so. Give you guys a couple minutes here to work through the challenge, and then keep it moving on here. Hopefully, everyone's doing well.
Okay, we're just gonna give everyone a minute or two. Okay. I know I don't see everyone's names there on the Google Docs, but that's okay. I think we can go over this together. So I'm not muted, am I? Okay, cool. Okay. Sorry. Sorry, I'm recovering from a cold, so my voice is low. Okay, that's better. So the challenge here was to filter on all the African countries and identify all the countries for the entries years 1982 and onwards. So there's a syntax here that you have to pay attention to. It's 1982 and onwards, so that's why the hint is greater than or equal to. Oh my God, so sorry. Okay, so let's go through each of the different options and say why they will and won't work. So does anyone want to tell me whether option A works, and if it doesn't, why? Anyone?
It doesn't work because you don't have the data before the filter with the pipe thingy.
Yeah, exactly. Great catch. Yeah, so we're telling filter there's something coming with the dot, but we haven't told it what. So exactly. Thank you so much, Heather. Yeah, so we needed Gapminder up here. So that's why option A wouldn't work. Okay, so let's move on to B. Can someone else besides Heather tell me whether or not option B works?
Option B does work.
Okay, option B does work. And you can all check that if you copy and paste this into your code, into your console. And we're not going to explain why it doesn't work, because I think it's more interesting to know why certain things don't work rather than why they do. Okay, so let's move on to option C. Sorry, so someone besides Heather and Caitlin, does anyone else want to chime in for option C?
I'll take this one if no one else is typing in, chomping at the bit. So this one will not work. Well, so it'll run, but you need to replace the greater than for the year with greater than or equal to.
Yeah, exactly. This was kind of a trick question. It's whether or not, the verbiage in the question above was if you spotted the and onwards up there. So yeah, it's just, it works, but it's not going to give you the answer that you expect. And that's really important when you're coding, is that sometimes what you're asking, what your code is doing will work because your computer or Rstudio is going to interpret it very literally, even though you want it to actually give you 1982 and all the years above it. It might not give you an error, and you might assume, oh, great, like everything worked, moving on. And then, later down the line, you might realize that the outcome is not what you've been expecting. So yeah, just because the code works doesn't mean you're, out of the woods. So great catch. So let's move on to the last one. Will this code work or not? Okay, so I am gonna be a little bit mean, so I'm really sorry. I'm just gonna pick on someone randomly. I'm gonna pick on, let's see, Tiffany.
Yeah, option D does work.
Okay, awesome. So option D does work. And yes, the difference between option D and option B is very subtle, but you'll notice option B is separated by a comma, whereas option D is separated by an and symbol. So this, I put this in here even though I didn't cover it, as just a demonstration of different ways you can filter or condition. So the and symbol is just saying all the continents of Africa and all the years above 1982. So this comma actually is acting as an and symbol. So if you want to put an or symbol, so the or symbol is, I'll show you here. Let me just copy and paste this over to my Rstudio. And this is the and symbol, and the or symbol is this one here, and that is on my Mac. It's right above the return button, but you need a shift key to get to it. It's like this bar. Hopefully everyone can find that on their keyboard. But
Yeah.
this is the or symbol, and what this will do is that it will, sorry, grab all the continents of Africa, regardless of the year, and it will grab all the different years above 1982, regardless of the continent of Africa. So it's a very different question, but something to be aware of in the future, because sometimes you might want different combinations for whatever you're asking. Okay, so good job, everyone. So that's challenge 2 down, and I think I have 4 challenges. I don't quite remember. But let's move on to our next function. It's called mutate. So mutate, what it does is that it creates a new column and adds different information depending on what you are giving it. So let's just, instead of me trying to explain it verbally, I'll do a terrible job, I'll just explain it with code. So let's say we want to calculate the total GDP of each of the entries. So we'll assign that to a new variable called gapminder underscore total GDP. And in this variable, we're going to assign gapminder, pipe operator, and our new function called mutate. And in mutate, we have to tell mutate what we want our new column to be called. And that's called GDP total is what I'm going to name mine. And that is going to contain, so equal sign. So we see 2 columns here that can give us total GDPs. So that's GDP per cap. Make sure your E on per is capitalized because that's important. Multiply that by population. That will give you total GDP of a country. And let's run it. And we'll take a glimpse of gapminder total GDP. And we'll take a look. And instead of 6 columns, now we have 7. It's great news because that's what we want to do. We want to create a new one. And if you look down, you'll see GDP total. That's what we made. And I'm not going to do the math because it's already done for me, but that looks like total GDP of Afghanistan in 1952. So these are ways that you can mutate. You can string mutates as well. So, if you wanted to make another column, so you don't have to call mutate every time you want to make a column. You can just keep adding to this. So we can put a comma behind pop, and we can double the population. So double pop is just going to be double our population. So that's population, multiply that by 2. And we can run this again and take a glimpse. And you should see double pop column with population times 2 in a new column. So these are new ways that you can create new columns using what you have in your data set. Okay, so now that we've learned a few different commands from dplyr, let's try to combine all these functions together, because that's really when dplyr becomes more powerful. So combining functions. Okay, and so for this variable, we're going to call this one getMinder, multi, for just multiple functions. Is not very creative. I'm going to call this getMinder, and we're going to pipe 2 different things. So we want to select 5 different columns. So it's a lot of typing, but it's good practice. So let's say we're going to select country, select year, select life expectancy, population, and GDP per cap. And we're going to pipe this again, and we're going to filter on country. That equals, well, let's do Japan because it's my hometown, and assign that to getMinder multi. And we can take a glimpse, of getMinder multi. And so here we should see both rows or 5 columns that we selected on only the country Japan. So the pipe operator, you can see that it becomes really useful when you want to string together different options. And one thing I will mention is that, so here we did it really inefficiently. So, we selected 5 out of 6 columns, and we have to do all this typing. And that's nice if you like the exercise, but oftentimes you want to do things in less text as possible, because I think the more you code, the lazier you get, and you're just looking for easier options, right? Or at least that's true for my case. So I'll show you another option to write this out. So I'm just going to copy and paste what I had up here, and I'm going to show you another way. So we know that we are selecting everything except for one column, and that column is continent. That's the only column that we left out. So we can actually indicate what we want to leave out instead of what we want to bring in, if that makes sense. So to do that, you do the minus, the hyphen, that's right next to your 0, and say continent. So negative is excluding the columns that you don't want. So we can run that here. And yeah, let's take a glimpse of this data, and it should look exactly the same. So I've shown you 2 very different ways of coding. Well, it looks visually different, but at the end of the day, it's actually giving you the same output. So you can kind of think of things, if you want to include certain things, just think about how many things they're including. Can you get away with excluding less things than including more things? So this is kind of, a lazy way of going about it.
Yuka,
Okay. Yeah.
Can I just ask if, just for everyone's understanding, you can also use indexing, correct? When you have select? So could you not do the column numbers?
Column numbers, specifically with select?
I don't know if you can, because I'm a bit old school when it comes to manipulating data frames.
You use the square brackets?
Yeah, so you could just select a number of columns in a range. So, can you not do that with select?
You should be able to use indexes with select as well. Yeah. So you could say like
Oh, really?
columns 1 through 5. I think it works.
I think so. If it should be, you just put in a vector, right? Like C 1 to 5. Try it.
I've never done it. So I'll explain why I don't do this. Oh, awesome.
Yeah, there you go.
This
Cool.
is what it's, yeah, awesome. I didn't know that. Yeah, you learn new things every day. I didn't know that we could do this with select. There are pros and cons to this, and I guess the pro is it's shorter, it's faster, and if you're always expecting country, continent, year to follow each other, 1, 2, 3, then great, use that. I will mention if you're coming from a different language, R counts from 1, not 0. So if that doesn't make sense to you, some computing languages are funny in that they like to start from 0. So 0 is actually a first value, and then it'll go 0, 1, 2, 3. But R was made by statisticians, and not computer programmers. So we count with 1 because to me that makes a lot more sense. And so if you're expecting your data set to always look the same, feel free to use 1 through 3. But just know that part of coding is also to make things reproducible. And what if one day you're expecting data, a collaborator sent you a data frame, and actually they put all the content first and then the country. And then, something else. So if things are starting to change, and if you're expecting variability, or if you're expecting to collaborate, be explicit about what you're selecting is really important. So this may or may not be reproducible in 3 months' time. So that's my reason of avoiding numerical selections. But if I know I'm just going to use this once and I just need to quickly do it, then this is a great way. Yeah, thank you so much for chiming in. And I also learned a new thing. It's awesome. Okay, so with that, let's move on to our third challenge. Okay, so in our third challenge, I want you guys, so there's no selecting, there's no ABC options anymore. Kind of amped up the challenge so that you guys have to code for yourself from scratch. And in this challenge, I want you to use select on all the columns except for continent and filter to show data only from Canada, and then calculate the total GDP for each of the rows and place it into a new column named GDP underscore total. And the hint here is using this negative or hyphen, which I showed you earlier what that does. So I'll give you guys a few minutes to work on this challenge. And once you're done, again, please put your name on the Google Doc. And as Travis always helps remind me, this is a really great way, a great time to ask questions. If you have one, it's really silent on my end, so I really like conversation. So feel free to chime in, pretend that we're actually in the same room.
Yeah, you beat me to the punch on that one, Yuka. Yeah.
I think with the indexing like that, you're absolutely right that it's not necessarily reproducible, but it's especially useful if you have a massive data set and you want to pull a subset of columns and you don't have to type out all of the names, right? So
Yeah.
I think for me, what I tend to do is write in a note to myself that I've done this kind of indexing and to check to make sure that they're in the order that I think, or just to go through the column names and make sure I'm catching the right ones again. But if you're selecting like 200 columns from something that's got 1,000 columns, you really don't want to type in all those things.
It's a very good point.
That's true. Have you used the colon function?
Colon.
So you can actually.
Okay, so.
Sorry, go ahead.
Let me show you. Oh. Okay, so let me show you what I mean. So it's very similar to the indexing that we did here, but instead of numbers, we can say country colon year.
Right. So all the columns between country and year. Yeah.
Yes. It's
I mean,
if you
it
know
has,
the names of those
yeah,
boundaries. Yeah.
it ends up having the same issues where if the ones in between are different, right?
Yeah.
Then you might
Yeah.
miss them again. So it has the same reproducibility issues, but yeah, it definitely at least tells you where you want to bracket it using words. That's helpful.
Mhm. And there is another one called everything. Select has lots of different quirky ways.
Yeah, there's a lot of like helper
Have you
functions.
encountered Yeah. Yeah.
So there's
So
like,
I'm just gonna leave it at this for now, but maybe Travis, if you can find a link to all the different variations of select, we can post that on Slack.
I can definitely do that. I think it's also in the help page for select, like inside of Rstudio. It should list a bunch
Oh,
of
okay.
helper functions. So there's like contains or like starts with or ends with if you're looking for like a specific suffix or prefix on your column name. I just saw one like you can do like a logic test. So you could do like if the column is a numeric column, pick those ones or something like that. Yeah, there's a ton of, there you go.
Yeah, I have it here now. Yeah, so yes, that's a great way. Yeah, definitely use the helper, the question mark to ask, to query what that function does, because oftentimes these help functions are really detailed, and sometimes you're missing a lot of really important key things that aren't necessarily what you're looking for right now. But if you sometimes spend a bit of time to look at the help functions of all the functions that you commonly use, you'll see, starts with, so you can say everything that starts with the letter C or everything that starts with the letter X. Those are different ways that you can query select. And yeah, if you can think of the way you want to do filter on or select on, there's usually a really easy way, and Google it. If you can think of it, I'm sure someone else also thought about it, and there's usually a really nice solution out there.
And maybe it's just worth pointing out so everyone knows if they're like Googling help for these kinds of things that there are a lot of non-dplyr options for manipulating data that they might see people using that, like there's 100 different ways to do these, it feels like sometimes. And so folks might be using sort of the data frame selection kind of tools using logical statements and so on, that those kind of helper functions are shortcuts of those logical statements that you could spell out using kind of more old school R. So you might encounter people using different kinds of code for selecting data or columns and so on from a data frame.
Yeah, that's really true. It's crazy how many different ways you can do the same thing. That's sometimes a huge challenge for someone new to a language because it's really confusing. So I'm just going to reiterate again that what we're showing today is everything, our grammars or functions from the tidyverse package. And it's not something that we use. These functions don't exist outside of these packages. So if you didn't download it and you only are limited to base R functions, so that's basic R that's automatically loaded when you open R, you can do everything that we've done today with base R as well, which would, I think, the entry to that it's a steeper learning curve than what we're teaching today, and that's kind of the primary reason we chose it. And also a lot of, well, at least in genomics, everyone's moving to the tidyverse in terms of everyone new coming into R. So what we're teaching you isn't like so niche, it's trendy. for now.
It's really the thing. Yeah, it's funny. It's just folks like me
Yeah.
who started with R 20 years ago that are having to catch up with the whole new tidyverse. But yeah, it's just nice to see that it's actually a lot easier to learn now than it was when I started.
Mhm.
It's quite nice.
Yeah.
Okay, well, I think we have most people have completed the challenge. So if we want to move on to the next one,
Okay,
next section.
cool. Thank you. Yeah. Okay, so maybe I should also reveal the answer. Well, my version of the answer for challenge 3. Sorry. So for challenge 3, whoop. So my answer, and it's not the only answer, is gapminder height, and we're selecting. We don't want to select continent, but we want everything else. So the challenge continent is to negatively select. I don't know what the best wording is. Anyways, use the negative symbol there. And filter for country only for Canada. And lastly, we want to use mutate. So these are all the functions that we use so far. GDP underscore total is the column we want to make. And we do that by multiplying GDP per cap with population. And this time I didn't assign it to a variable. And you can just do that and it will just spit out the answer in your console. It just won't save it, but you can see the answer real quick. Okay, so if you didn't type this exactly, that's totally fine, like we've been discussing so far. But as long as your answer contains 12 rows, 6 columns, and everything says Canada, I think you're all good. Okay, so let's move on. Sorry, we're eating into your time, Travis. Oh. Are you okay with covering one last section? It's just group by and summarize, and then I think it's 3 more actually, and join functions. Yep.
Yep, it's fine. If you want to do group by summarize and then maybe just left join, because we do want to give people a break here as well. So
yeah, and we'll just skip the challenge. But if you want to do the challenge, it's on the website, and so go for it on your own time. Okay, so let's move on to group by and summarize. So this is a little tricky, so I'm going to show you an illustration of what this does. So when we say gapminder group by A, what it's doing is, okay, so imagine this to be your gapminder data frame. You have columns A, B, C, and D, and you're saying group by column A. And in column A, you have rows containing 1, 2, and 3. Imagine these to be like your continent. You have Asia's, a bunch of Asia's, a bunch of Africa's, a bunch of Europe's, stuff like that. And you're grouping by A. So what this means is that it'll pull everything that matches within a group. So all of 1 comes here, all of 2 comes here, all of 3 comes here. It parses it, and then it summarizes. So once it's grouped into these individual groupings based on column A, it will perform a certain function, which we're using here as summarize. And what this is doing is, creating a new column called mean underscore B, which is the mean of column B. So it basically takes this and calculates the mean per these groups. And then it creates a new data frame where it shows you each of these groups and the mean score. Okay, so that's as much as I can do with words. So let's, give it a go, and maybe it will make more sense to you when you see the results on your end. So let's do this. So let's use gapminder. and we're going to pipe that, and we're going to group by. We're going to group by country. Pipe that out to summarize. And so this is the British way of spelling it, because the original makers of, so the people who produced R, or producers, the people who invented R, I think they're from New Zealand, and so therefore they like to use British spelling. If you are American and prefer American spelling, we can use a Z here, and that would work as well. And since I'm in Canada, I'm trying my best to learn Canadian, British spelling, so we're going to use the S. And so let's calculate different outputs of life expectancy, or like different summaries of life expectancy. So we're going to calculate the max of life expectancy per country. So that's max life expectancy, comma, and we're also going to calculate the minimum. So min. And lastly, we will also calculate the average. And that function is called mean life expectancy. So let's run this code, and something isn't working.
You have caps for life expect when it's in lowercase l.
Thank you. Yep. Yeah, so case sensitivity. There we go. Thank you, Caitlin. Okay, so once I fix my typos, you should see each of the countries. Sorry. And you should see the maximum life expectancy for that country for all the years, the minimum, and the average over the course of the years. That's collected at Gapminder. So I hope that made sense. So let me just try to verbally explain what happened here. So everything from Gapminder is being grouped by individual countries. Just imagine those little small boxes. Those small boxes are all countries. And within the small boxes of the subset, we're calculating the maximum, minimum, and mean. And we're telling it to print it out in a new column called life expect underscore max, min, and average. And that's what we're getting here. So it's a quick summary of our data. The other thing we could do that sometimes could be useful is we might want to just take a count of how many different, countries we have for, say, continent by year. So Gapminder, and pipe that to group by, and we can group it not only by a single column, but you can combine two columns. So let's do continent and year, and we're going to pipe it to a new function called tally. So it's going to tally everything that we entered here. And what you'll notice is for each continent for every year, so if Africa, so this continent, so all the different countries that are contained within Africa for this given year, let's count how many there are. So it's saying there are 50 entries for each of these years. So I could probably know that there's 52 countries from Africa that are represented in the Gapminder data set. So these are different things that you can do with group by, not just summary, but also tally. Okay, so we're going into our last function, and then we're going to take a break. So stay with me. We're going to use join functions. And to illustrate what we're about to do, I'm going to bring you guys back to the website here. So imagine A and B are two different data sets, and you want to join them. but there are different ways you can join them, right? So you can join them by everything that's from the right side, but taking information from dataset B, or you can take everything that's in dataset B and that matches dataset B from dataset A, or you can take what's common between the two data sets, or you can take everything, which is a full join. But for now, we're just going to show you what a left join does. So left join looks at everything that's in common between A and B, but it will only show you all the entries from A. But if there are entries from B that doesn't match A, it's excluded. So let's give that a go. So for left join, we're going to use a different data set. So we're going to use band members. So band members is a data set that's already downloaded. I think it's base R. It's a data set that's already there for you to use exercise. And the second one we're going to use is band instruments. So band members, you have the Rolling Stones, the Beatles, and you have band members, which gives you the name and what instrument they play. So between these two data frames, it's a very small data frame, there's one thing in common, one column in common, and that's name, right? So let's join the two together. So let's say left join, open parentheses, we'll say band members first, whoops, and then band instruments. And the order of this is really important because if you put band instruments first instead of band members, left join is going to match everything that's contained on the left one, well, the left data frame here. So make sure if you're doing left join, what the data frame that you're expecting to still have fully is the one on the left. And so if you join it, let me make this bigger again. So we have band members first. So band members, we have Mick from Stones, John from Beatles, Paul from Beatles, right? And we can see that for Mick, for some reason, like we don't have the instrument that he plays. And if we look at the instrument data frame, we don't have an entry for Mick from the Stones. So this is why it gives you an NA. It just says, hey, like we don't have an entry for you from this one, but we do have someone from John, an instrument for John and an instrument for Paul. So this is where, left or right joins, you have to really pay attention to what is on the left and what is on the right. Yeah, so I am gonna wrap it up there. There is a challenge if you don't want to take a break and you still want to keep going, which I'm happy to hear, but don't worry if you don't, because we are gonna take a 15-minute break. Is that okay, Travis?
Yep, that works.
Okay, so let's take a 15-minute break. That would bring us to
just before 8, I guess.
Just before 8, yeah.
Few minutes to 8, we'll say we'll start up again. Okay, so where'd it go? Here we go. So we had a question in chat for those who maybe didn't see it, is how to deal with NA values. So let me just kind of get rid of some stuff here. So you can see I'm unmuted, right?
Yeah, I can hear you.
Okay, sorry. I just lost my Cisco window, so I was like, oh, whoops. Sorry, one sec, let me fix this. So we had a question in the chat, what to do with NA values. So you can see here, because in the band instruments table, we didn't have an entry for Mick. So we ended up with this NA in our plays column. So we had a question about how would you go about if you wanted to replace that NA with something else. There's a bunch of different ways to do it. I'm going to give 3 different ways here, which seems like probably a lot. There's probably more. So one way, and this is what kind of my initial idea was, is there's actually a replace underscore NA function, which is also part of the tidyverse. And then you can provide a list, and then you specify like for each column where you want NA values replaced, what you want the replacement to be. So you could say, in our plays column, replace any NAs with 0. And then if we run this, so you should see on the right, it's replaced this with 0. And then Yuka also mentioned one in chat, which is using mutate combined with another function called case when, which is a little bit like more, I guess you could say maybe advanced, but is really, really useful. So basically this mutate is going to kind of overwrite our plays column. And it's going to do this in such a way where like anytime it finds an NA, it's going to replace it with 0. So plays is going to become 0 if it's NA. And in any other case, so when like, so the true is sort of like any case besides the one you kind of explicitly mentioned, it's going to just replace the value in plays with the value in plays. So it's going to keep it the same essentially. So if we run this, you can see we get essentially the same result, or exactly the same result, I should say, which is great. You'll notice like the 0 in this case has to be in quotations because the plays column as it is a character or a string. And so you can't, if you tried to do this with like 0, the number, you should, get an error because it's having issues. There's like a 0 is of type double and the column is a character. And so it doesn't work. So you need to put this in quotations. And again, that should work. And then one other method I'll mention is using the replace function, which is different than the replace NA. But you can use replace and then say like replace any value of NA, and then the dot. The dot is just like before from our select, is kind of like our placeholder for what's being piped. And it's going to replace that with 0. The one thing to mention with this one is it's going to replace any NAs in the data frame regardless of what column. So do be careful. If you do use this, know that like it is not specific to any one column. It's going to apply it over the entire data frame, which sometimes, like depending on what you're doing, you might want that, but it's just something to be kind of aware of. You don't accidentally change columns you don't intend to. So probably one of the first two would be, in most cases, preferred. Okay, so I think we are.
Travis.
Yeah.
Can I just add one thing?
Of course.
So I mentioned this in the chat as well, but whenever anyone wants to replace NAs with a certain value, I always feel the need to mention this, is that, NAs mean a very different thing as a 0. So if you have a measurement that your machine is measuring certain things and storing NAs and 0, so what do they actually mean? So NAs could mean, for some reason there was an error in the machine and the observation something couldn't be measured. So there's missing data. Otherwise, a 0 could mean a real measurement. So the measurement of, the protein for, from the cell was actually 0. It wasn't missing. It was measured, and there was nothing. So just keep in mind that when you do replace values from your data set, just think about what they actually mean before you go ahead, because it can actually throw your analysis down the line. Okay, I'm done. Thank you.
Yeah, no, that's a very good point to mention. So actually, in that case, to kind of follow up with that, you might be better off, like, instead of 0 in this case, maybe do just like unknown or something like that. I can type. There you go. And then it's not kind of, and if another column of 0 was meaningful, it's maybe not going to be quite as ambiguous. So anyway, enough of that. We're going to do some quote unquote fun stuff now. So we're going to talk about plotting using R. So I'm just going to switch over to my lesson here really quick. So Yuka did a great job there of going through how to kind of manipulate your data and get it into what we kind of often refer to as like a tidy format, which is just kind of like a specific type of, specific way of organizing your data so that you can then make nice, beautiful plots with it. And specifically, we're going to look at the ggplot2 package. And then hopefully, if we have some time towards the end, we'll be able to fit in the core plot, which is for heat maps, which depending on the type of data you work with might be very common. But we're going to start with ggplot. just with some simple stuff. So you should already have tidyverse and gapminder, excuse me, loaded in. So we're going to start off with this nice simple example. So I'm going to switch back over to our studio here. So we're doing GDP per capita and life expectancy. So I'll just add, oh, can't type. First, so we're going to start with the ggplot function. And then the first thing we need is our data, which is gapminder. And then to specify like our X and Y axes, we need to put them inside of the AES or aesthetics function. So we can say X equals, let's just swap back real quick here. GDP per cap, and Y was life expectancy. So that kind of sets up what we want our data to be and what we want on our X and Y axes. And then we do plus, so not the pipe like we were doing earlier, but the plus sign. And then I'm going to start a new line just so that it all kind of fits on the screen here. You can do the same. And then we want to tell it sort of what we want to, or how we want to visualize this data. And we do that with gems. I don't know if that's the correct pronunciation, but I prefer it to say it that way. It's like a gem point, which is going to create like a scatter plot essentially. And then again, I'm just going to highlight and control enter to run. And I'll expand this. So the console is going to be a little hidden there for a second. Oh my God, load.
Travis, when I write it, I pronounce it geom
Yeah.
or geometry.
Oh, that also makes sense.
Yeah.
Geom also is probably, well, it's probably correct, let's be honest.
But I like gems, so it's kind of nice.
Oh.
You know, they're like rubies and jewels out there for other coding languages.
So yeah, you can see here we have a kind of very basic scatter plot with GDP per capita on the X and life expectancy on the Y. So you can see like with R, it's really nice if you're doing figures a lot. Like with these simple, like barely 2 lines of code, we have like not a great looking figure, but certainly decent. And it's very simple to use and hopefully fairly intuitive. So that's great. Now that we've done that, we probably want to get, you know, maybe a little bit more complex. So I think we've done all this. I'm going to skip the kind of layer stuff. I'm not going to spend too much time on it, but know that as you add lines to your ggplot call, it's kind of building your plot in layers. So the base gets laid down and then our gem point, and then anything after that would be kind of overlaid on top of our plot, and we'll kind of see examples of that later. So that's the same. So we have this challenge here. I think I might actually skip it for now just so we can try and get through some more material, but basically we're just asking you to kind of plot different variables instead of GDP per capita and life expectancy. Here we're looking at the year and life expectancy. And I'll just pause here for a moment so you guys can see what this, actually I'll scroll up. Oh, geez. I can show you the code as well. So you can see in this case, we've said X for our year and Y for the life expectancy. And again, we've said gem point. And you can see that's exactly what R has returned to us, is a nice looking plot of year and life expectancy. So, oh my God, we have another challenge. Okay, this one I'm going to kind of talk about. So in this case, in the previous ones, we've just mapped our data to X and Y, but you can also map your data to, for example, colors. So I'm going to kind of flip back to Rstudio here. I'm going to say changing color based on continent. Hope I spelled that right. So we're going to, again, do ggplot on our gapminder data. And then we need our aesthetics. So our X is, our X was year. Yes, year. And the Y was life expectancy, I believe. EXP, correct. Yes. And then we can actually add a color argument. So you can do color equals continent in this example. Continent And then again, we need to specify points. I'm just going to adjust this really quick. Our geom point. And then I'm going to just Control Enter to run. And you can see now each of our points has been colored by the different continent, and it's also placed a legend on the right-hand side here, so we can see, countries from Africa tend to have a lower life expectancy compared to those in somewhere like Europe. So that's really great, and it shows you just more ways you can kind of get information out of a simple plot. And I think the next part, so we're gonna talk a bit about those layers we were mentioning earlier. So, in the example we just did, the scatter plot probably isn't the best for trying to look at changes over time. So instead, we can use, or in ggplot, we can actually create a line plot instead. X and Y. Great. So, okay, so I'm going to go back to our studio here. And so we're doing line plot for life expectancy and time. So again, starting with ggplot, on our Gapminder data, our aesthetics, and I'm just gonna, so basically your aesthetics function is going to assume your first and second arguments are the X and Y. So we can actually kind of shorthand this and just say year and life expectancy. Expectancy. And then for our line plot, we're going to need this by argument, which is, I think, country for this one. Oops. And then we can again color by continent. And then finally do our plus, and this time doing geom underscore line here. R is telling me something is wrong. Oh, brackets. Aha. So I missed a bracket there. So we have one open bracket for ggplot and another for aesthetics. So we need to make sure we're matched up on the other side as well. So we should be able to run this. And once it loads, it will give you a nice little line plot showing how the life expectancy for all of our different countries is increasing over time. And then again, it's colored by continent, so you can see kind of where different countries sort of end up. And then to kind of expand on the layers aspect. So yeah, if we wanted to do points and lines, you can see we can actually just add in our gem point after our gem line. So again, I'm going to swap back. I'm just going to copy and paste this down below. Just say like adding points to the lines and paste that and do gem underscore point. So again, that's ggplot on Gapminder, year on the X, life expectancy on the Y, grouping by country, coloring by continent, starting with our line plots and then doing our points over top. So it might not be super clear on this one, but I think the next example will make it kind of more obvious. But our points are essentially being overlaid on top of our lines. Again, because of the colors, it's a little bit tricky to see on the screen right now. But again, it is going to be building it kind of one line at a time. So that's something to keep in mind depending on how many layers you have and how you want your final plot to look. And I think the next one, yes. Okay, so to make that kind of maybe more clear, I'll go to a new section here. So we're going to change the colors of our points this time, and I'll type this one out because it's we're going to change a kind of a couple things here. So again, ggplot on Gapminder. Our aesthetics are year and life expectancy. For our X and Y, we want it to be by country. And then we're going to leave it at that for our first ggplot call. And then go on to our gem line, or geom line, and say, again, inside of aesthetics, color equals continent. And then after that, add in our points, which should not need any other arguments. So again, on this gem line call, make sure your color is inside of another aesthetics because we are, mapping that aesthetic, mapping our data to the aesthetic of color. So anytime you're trying to kind of map your data to either like an X or a Y or color or shape or anything, any kind of attribute of your plot or aesthetic of your plot, it needs to be inside of that aesthetics function call. So if we run this one, oh, I spelled gapminder wrong. So we will fix the typo and then run it again. And now you can see probably a bit more clearly that our black points are showing up on top of our colored lines. And again, the reason our points are not colored is because in the ggplot call, we've only specified the X, Y, and this by argument. The color was specifically placed, I should say, inside of the geom line, but our gem point had no such information passed to it, and so those points were just left as black. And again, this is partly just to illustrate that your plot is being built kind of in layers from the base, and then the lines, and then the points over top. So hopefully that kind of makes sense to everyone. And I'm going to flip back here so we can see what's up next. So again, when we're setting an aesthetic to a value, it needs to be in the aesthetics function. So like this right here. So gemline aesthetics color equals continent. If we just wanted to make all of the lines, for example, blue. So again, like kind of initially, you might think you want this. So aesthetics and then color equals blue, but this will not actually work. You need to specify the color outside of the aesthetics because this time you're just wanting to apply that color to all of your data kind of consistently and not have it vary based on what your input is. So we can do that example just to demonstrate. So again, we'll do ggplot on gapminder, and our aesthetics will still be year and life expectancy. Oops. And we still want our by to be country. And then our gem line. And this time, again, we're going to leave out the aesthetics and just say color equals, and we can just say blue. And then again, add our points. So gem underscore point. And maybe let's make our points red because that will look great, I'm sure. So here we go. Let's take a look at that. Yeah, as I said, looks wonderful. But you can see that now like all of our lines are blue consistently across our whole data and all of our points are now red. So again, just keep in mind, if you're mapping something to your data, it should be inside of aesthetics. If you just want it consistently for all of your data the same, keep it outside of the aesthetics.
Can I add one thing, Travis?
Yeah, of course.
So for me, when I think about aesthetics, I try to think that aesthetics is pulling something out of my data. So when you say aesthetics color equals blue, it's actually looking for a data set, a column named color, and looking for a value named blue. So it's actually looking for a column named blue, sorry, and that doesn't exist. So oftentimes that will throw an error. So just think of aesthetics as something very specific that you want to pull from your data. And anything outside of that has nothing to do with, isn't very data aware.
Yeah, perfect. Yeah, that's great. It's a great way of explaining it. So again, I think I'm going to pass on the challenge here just to kind of show you guys we're essentially just swapping the order. So putting our points first and our lines second, and you can see now our lines have been drawn over top of our points. again, just to reiterate the idea that you're kind of building your plot in these layers as you go down and add more and more lines of code. So we're going to move on now and look at some statistics, which depending on what kind of work you do might be super common. So we wanted to cover this at least briefly. So we're going to go back. Again, I'm going to swap back here to Rstudio and just do a plot of GDP per cap and life expectancy, and then color by continent. So let's say scatter plot, GDP and life. Oops. So ggplot on Gapminder. Our aesthetics are GDP per cap and life expectancy. We want to color by continent. Honestly, let's do it that way. And then geom point. It should be a yep. So again, we have this nice plot of GDP per capita and life expectancy colored with each of our points colored by continent, but it's kind of hard in the plot with that shape to see kind of what the trend is, and our points are like obviously super kind of clustered together, so you can't really tell what's going on or can't tell one point from another. So one thing we can do, well, we can do a couple things. One of them is to set the alpha value of our points. So this alpha essentially controls like how opaque or how transparent your points are going to be. So this means they're going to be like 50% opaque or 50% transparent, depending on how you want to look at it. Just so there, you can see in the example here, which we'll go through, that like when they're stacked on top of one another, they start to get these kind of darker clouds versus the individual points remain lighter. And then we can actually also scale our axes on, like, let's say by log 10, which kind of helps spread our points out and make trend a little bit more visible. So again, I'll swap back to Rstudio here, scaling and alpha. So we'll do ggplot on Gapminder. Our aesthetics, again, are GDP per capita and life EXP. We are not setting a color this time. We're just going to do gem underscore point and say alpha, again, which is that transparency. And again, because we want it to be consistent and not mapped to any part of our data, it's left outside of any aesthetics calls. So we'll set it to 0.5. And then finally, we're going to scale X and then log 10. So there's, should say, as you're typing, you can probably see there's a whole bunch of different scale options here. We're not going to go through all of these today, but just know that they exist. So there's a lot you can do with your data. Scale log 10 should work. Sorry, one sec here. I feel like that should work.
Your alpha is spelled wrong.
Ah, it is. Thank you very much. The dreaded typos. And this needs to be log 10. Oops, and bracket. Okay. And too many brackets. Okay. Even after 2 years. All right. So there you go. Now we're finally able to replicate that plot. You can see it's like a little bit more interpretable now compared to the earlier examples, which is really great. So the next step, again, I'm going to kind of swap back here. So again, just to go over it, so the log 10 is being applied to our x-axis, which is GDP per cap, which makes our data kind of like spreads it out a lot and makes it a little bit more, or a little easier, I should say, to kind of interpret what's going on with our data. And again, just another reminder once more of setting aesthetics to values versus, or sorry, setting aesthetics to like a fixed value versus mapping it to your data. So for the alpha here, we want that consistent for all of our points. versus trying to map it, say, like onto continent, which you could also do. Actually, you know what? Why don't we? I'll just very quickly copy this over just as a demonstration. And see what that looks like if we map our alpha to one of our variables instead of just setting it to be consistent. And then we'll add in our scale log, scale x. So you can see it might be hard to see over the screen sharing, hopefully. You can see that now like our points are being given different transparency values based on the continent, which, you know, in this case is not very practical, but it's something you could do. But it's just good to keep in mind the difference of setting aesthetics versus setting kind of a constant value.
Can I pop in for just a second?
Of course.
One thing that I really had trouble with when I first started using ggplot and that I'm noticing here is, so in your scatter plot of GDP and life exp, line 36 to 38, you sort of like, you pop your color equals continent up top. And that totally works, and you can get the exact same graph by putting that into the aesthetics argument in your geom point.
Yes.
And so one way to think about it and you can like just run around in circles for hours trying to figure out why your argument's in the wrong spot. And so one way that I found to think about it that keeps me from running around for hours doing that is by thinking of this ggplot argument as just setting up your x and y axes, and then anything else about how your graph is going to look will go in the following arguments. And so I just noticed that you did that with this down here where you put alpha equals continent. And so I just wanted to clarify that and yeah, just raise that in case anyone else noticed that hopped places, and it did the exact same thing. And it's just sort of two different ways of visualizing what you're actually trying to do with your data for the graph.
Yeah, no, that's a very good point. And yeah, kind of maybe next time we'll change this so it's a bit more kind of consistent. But just to kind of illustrate Kaylee's, I apologize if I mispronounce your name. To illustrate your point, we can do it, you know, saying color in the first ggplot call, and we get that. And if we now do the version where we've moved it into our gem point, and run it again, right, we get the exact same plot. So, but yeah, that's very good to point out. Typically, when I make plots, I put all of my aesthetics in this first call, but depending on how many layers you're building, it might be a lot easier to kind of separate them out into each of your geoms. Kind of just depend on what you're doing, but I agree for consistency's sake, this should probably get changed in the future, just so we don't cause any undue confusion. But yeah, thank you for raising that point. That was very good.
And just to add a little bit of technical differences between the two. So when you have your alpha, for example, on the first line for ggplot and the aesthetics there, it sets everything in the first line between the brackets for ggplot. It sets a global environment. So whatever is set there will be applied to everything below it. Mm-hmm. So for example, if you have a different geom, say box plot, and your alpha is at the first line for the global setting, your alpha will also be set for that box plot. But sometimes you might want some like finer tuning and you want more local. So if you want the alpha to only affect your geom point, then you want that within geom point and not at the very top. So the way I think about it is like global setting and then more local settings that are within the geoms.
Yeah, that's great. Thank you. Okay. So now we're finally going to get on to the sort of more kind of statistical portion of this. Not too much though, don't worry. So we're going to use another geom called geom smooth, which is going to kind of fit a line to our data, and you can specify sort of different methods. So in the example we're going to go through, we're just going to do kind of like a linear model, which is LM. And again, if you were to check the help page for gem smooth, I'm sure it would list all the different methods that you could apply to your data. So, okay. Okay, so with that, then this one. So I'm going to copy and paste our code from above. So adding let's call it a trend line to our data. Again, so in this case, we're doing ggplot on Gapminder, X as GDP, Y as life expectancy, setting an alpha value for all of our points, scaling our x-axis, and then adding our geom_smooth. And then saying we want our method. And yeah, there you go. So you can have linear model, generalized linear model, GAM, whatever that is, Loess, etc. I'm sure there's lots of different ways you can do this, but for now we're just going to stick with our simple linear model, and we can just run that. And you can see it's actually given us our some output on how it's kind of building our model here, so just Y and X. And you can see now we have this nice trend line showing kind of the general trend, I guess you would say, in our data. So it's a really nice kind of simple way to start adding some more information onto your plots. So yeah, we can kind of change the appearance of our line similarly to how we would change the color for our points or anything. We can change the size of our line to make it a little bit larger. So I'll swap back here. And again, I'm just going to copy and paste this code. So doing the same plot of GDP and life expectancy. And then in our gem smooth, saying size equals 1.5. Actually, no, let's go up all the way up to 2. So you can see now we have a thicker line on our data as opposed to before. And we could probably also change the color. See if this works. Yeah, so there you go. So just like you could alter the appearance of your points, you can alter the appearance of this trend line that we fit to our data. So yeah, that's really nice. And swap back here to our lesson. Again, maybe I'll just kind of go through the challenge, or you know what? I will skip the challenge for now. Hopefully you guys didn't see, oh, there's so many. You didn't see too much, so I'll leave that for you guys if you wanted to go back and try it on your own time. So we're actually going to move on now to building kind of multi-panel figures. And so earlier we were looking at the change in life expectancy over time across kind of all of our data, but we could also split this up into different panels or facets. So firstly, we're going to actually make kind of a smaller version of our data just to make it a little easier to work with for us. And so we're actually going to introduce kind of a new operator or a new sort of, I don't know, modifier or something like that, which is the %in%, which is going to test that our data is equal to one of the specified options. So again, I'll type through this, but just to show you guys for now, we can filter our Gapminder data into a new Gapminder small, and we can say we want to filter that data for where country is in or equal to one of these options. So Canada, the US, France, or Australia. So this is kind of equivalent to doing like country equals Canada or country equals the United States or country equals France, et cetera, et cetera. But it's just a sort of condensed and simplified syntax or a way of writing that code. So again, I'm going to swap, so Canada, US, France, Australia. So I'm going to swap back and say make a small version of our data frame. So Gapminder small, oops. It's going to be Gapminder pipe to filter. And then we want country to be like one of, or to match one of, so %in%, and again, no spaces or anything in there. And then we're going to use this like little function, which is C, which is short for concatenate, which is going to basically tell filter to match our country column to one of the options inside of this little C function. So we're going to do Canada and United States and France and Australia. Ooh. Oh, I missed a quote. Hold on. Typos all the time. That should be good. And then just to show you guys, so we'll do a glimpse on our Gapminder small. So let me just scroll this down a bit. So you can see now our data, as opposed to the original like 1700 or whatever it was, we now only have 48 rows in our data. And so our country is all, excuse me, always going to be one of these, the ones that we specified here in C. So now that that's done, we can make a faceted plot of our small data. So we can do ggplot and make sure you specify Gapminder small. Oops, Gapminder small this time. And let me check our aesthetics here. Year and life expectancy. So I'm going to follow the previous kind of example or suggestion, I guess, and do gem line. Let me check this real quick. Yeah, gem line. And our aesthetics, we want color equal to continent. And then in order to get our faceted plot, we're going to do facet. Oops. There's a couple options. They just kind of determine how your facets end up getting laid out. So for this one, I think it's just facet grid. Facet wrap. Okay, well, facet wrap is just kind of a little bit more flexible, I believe. So we'll go with that. And then we basically now want to tell facet wrap what column of our data frame we want it to use when creating our different facets. And to do that, we need to use the tilde. So it's a little squiggly line, which depending on your keyboard should be next to like the number 1. And you probably need like a shift in order to access it. So we do want to do tilde and then country. And we should be able to run this and it should work. Ah, there you go. So you can see now for each of our countries, it's created kind of a separate mini plot and then drawn our gem line as specified. And for all of these, we've colored based on the continents. You can see Canada and the US are red, Australia is blue, and France is green. So yeah, this is a nice way if you have, instead of having all of those lines kind of overlaid on the same plot where it might be kind of hard to distinguish them, you can fairly simply kind of separate them out and still be able to kind of compare the trends across, in this case, the different countries. So keep moving on here. I apologize if I'm moving a little quickly, but I just would like to try and get through as much of this as we can tonight. So the next thing we're going to talk about is how to kind of clean up our figures and maybe make it look a little bit nicer. So you can see like in our example, we had like the life expectancy is this like just the name of the column. So life exp, where you prefer it to be like life expectancy, like the full words. And maybe you don't like other aspects of your plot. You just want to kind of change some things. Even making like continent uppercase in the legend and maybe setting like a title or something like that. So we can do all of that inside of R with our ggplot functions. And this is what our resultant plot is going to look like. So we're going to go through all of this. So do not worry. I'm going to swap back here. And again, I'm just going to copy this down and say, modifying our faceted plot. And again, just copying the same code we used to create this one. we're going to add a few more arguments. So the first one is our labels. I'm going to go down on a new line here just to hopefully make it more visible for you guys. So we want our X to just be year, like change that to a capital. Our Y-axis we want to be life expectancy. I think that's spelled correctly. And maybe we want like a title. So like changes in life expectancy over time. And again, like our continent here, continent on our legend is lowercase, so let's make that uppercase, so that's color. So because we mapped color to continent, to change this title, we do color equals, and then continent. And I think that's all for the labels, and then another plus. So now we're going to change the theme. There's actually, if you do theme, and you can see there's a whole bunch of different options that you can use apart from the default, which I think is the gray. Maybe, yeah, I think it's the gray is the kind of default one we have, but we can change that to, let's say, theme_BW, which is like kind of black and white. And then finally, if we want to get even more specific, there's the just general or generic theme function, which has about a bazillion arguments that you can change pretty much every aspect of your plot. So in this case, we want to maybe just get rid of the ticks, or sorry, get rid of the year numbers along our x-axis, and then also get rid of the ticks on our x-axis. So like these little guys here, but on our x. So if we swap back to R, again, I'm just going to do a new line so it's a little bit easier to read. I'm going to do this axes.text.x. And the way we need to kind of edit anything inside of this theme function is with one of the kind of element functions. If you try to do like just blank, like you just wanted to do like an empty string, for example, that's not going to work. So you need to make sure whenever you're working kind of inside of this theme, you need to use one of the element functions. So we're going to do element blank if we just want to kind of make that thing blank or make it go away. And then again for axes dot ticks. Yeah, ticks.x, right? Yeah, there it is. Again, on just element blank to make it not appear. And then if we run all of this, hopefully it works. And I'll make this a little bigger. A sec. So now you can see we've added a nice title. We've changed the X and Y axes. We fixed this lowercase to an uppercase, and we've cleaned up our X axes overall. So it's a lot kind of easier to read, and you can focus more on the data as opposed to, you know, what are the X axis labels or something like that. So this theme function is super, super powerful. I'll show you guys just super quick. If you do $theme and then enter, you can see like even the scroll bar here is just enormous, and there's just a million different options you can mess around with to really kind of tweak your plot however you prefer. Yeah, really, really helpful, but a little intimidating at first, but there's a lot you can do, so don't be afraid to kind of just dive in there and start playing around with it. But for now, we are going to talk about how you can export your plot. So, you know, you've made this wonderful plot. It looks so great. We're so happy with it. Now we want to save it and send it to our boss or something, who knows. So there's a few different ways in Rstudio that we can save plots. One of them I'll show you guys is using right above your plot, there's this export button. So if you click that, you can save it as like either an image or a PDF. So we could say like save as image. And then by default, it's going to go into your working directory, if you remember that from our kind of earlier discussion. So we can just say this is like year and life expectancy line for plots.png is the default. It's not showing up for some reason here. There we go. And then you can click save, and I'll just open up so you guys can see. Here we have our plot that we've exported. And yes, Windows, I want to use photos to open a photo. And there you go. We have a nice PNG of our life expectancy plot. So that's one way to do it. But we're programmers, right? So we don't want to click on buttons. We want to write code. So another way is using the ggsave function, which will kind of by default save whichever plot is kind of most recent. So like what it comes down to most of the time is whatever is like directly above it. That's what it's going to save. So we can again do, year, life. Yeah, it'll probably come up again because we're in the same spot, and just call it V2. And maybe we want this one to be a PDF because it's maybe a little better quality, and you can just run that and it'll save it for you. And then again, I'll just show you guys really quick. So here's our second plot, and we can open this up. And ta-da, there you go. Nice high quality, high res PDF of your favorite R plots. So that's really great. And you can also do SVG as well if you wanted to edit it in like Adobe Illustrator, is it? Or like Inkscape or anything like that. So this kind of makes it really, really flexible when you're making plots in R. If there is something you can't do directly in R, you can always export it as an SVG and use another program to make your changes. So, defaults of the last plot, I think we got all that. The cheat sheets, again, I'm gonna kind of pass over the solution. Don't look, you can do that later. So we got about 15 minutes here. I'm gonna just very briefly go over some core plot stuff. So there's a lot that ggplot can do, but it's making heat maps with ggplot. They don't look great most of the time. It's not really built to make that kind of figure, especially if you're trying to do like kind of clustering based on similarities and all that kind of thing. So what we're going to use instead is this other package called CorePlot, which you should, again, all have installed. And we're going to use another different data set this time from our Gapminder. We're going to use the mtcars data set, which you shouldn't have to load or anything. It should already be up and running for you inside of Rstudio. So I'll switch over to R here and say looking core plot. So again, I need to load core plot in with library, and you can run that. So it's been loaded. That's great. And then instead we'll do glimpse instead of head on our mtcars, and make this bigger for you guys. So we have a bunch of different columns, miles per gallon, cylinder, displacement, horsepower, et cetera, et cetera. So this is the data we're going to be using to make a few heat maps. Finish off the night. So the first thing we're going to do is create kind of like a correlation matrix, which is going to tell us how correlated, I guess, each of the different variables in our data set is to the other. So we can do that with just the core function in R, and it's going to default to using the Pearson method, although there, again, just like the gem smooth, there are other methods you can use as well. So again, calculating correlations. So we can do like mtcars core is equal to correlation on our mtcars data, and we can just specify it just like that, and it'll run the default Pearson. And again, I'll do glimpse on mtcars core. Well, okay, it doesn't really display that great, so maybe we'll try head on this one. That's maybe a little bit better. But you can see, like, of course, MPG and MPG has a perfect correlation, which makes sense because they're the same. And then the negative correlation between MPG and cylinders, and et cetera, et cetera. So it's done that for all of our data, all of our different columns. And then we'll start with just a basic correlation plot. Oops. Where the size of the dot and the color indicates the correlation. So large blue dots is like a large positive correlation. Smaller, kind of more white dots is a weaker correlation, and then larger red is a strong negative correlation. And as you can see, like, it's very, very simple to build this plot. We just do core plot on our data and tell it we want it to be circles. So I'll switch back to Rstudio here, say making a basic core plot. So core plot on mtcars core, and what was the argument? Method equals, and we want circles in our plot. Circle, not circles. R is very picky. So there you go. We have our nice little correlation plot from all of our mtcars data. And yeah, so you can see this is kind of how it looks by default. And if we go back, switch back over here, we can also change it to using squares instead of circles. Obviously, this one is fairly simple, so I'm just going to skip on to, okay, so we also have the numbers here if you just want to display the raw values instead of like a dot or a square or anything like that. I'd like to get to, yeah, this part's good. So of course, just to scroll back up, because of the nature of this heat map, we sort of have like redundant data in the top right and lower left-hand portions, because it's like a mirror image of what the other. So we can actually reduce that down to just either the upper or lower portion, excuse me, by specifying the type. So I'm going to copy that and do, so core plot again on mtcars. And we'll just say our method, let's do squares this time. And our type is going to be upper, so we just want kind of the upper half of our correlation matrix or correlation heat map. And that doesn't work because it's a plural again, so there you go. And there, now we have kind of our reduced heat map where you've kind of stripped out some of the redundant data, so it's a little bit cleaner and kind of easier to look at if you're especially dealing with kind of larger heat maps with more than, I don't know, 10 or so, whatever number of variables we have here. And then, and again, you can do the same thing, but take, sorry, I'm gonna grab some water here. So we can do the same thing, just taking the lower portion of our correlation plot just by saying type is equal to lower. And you can also mix together different display types in the upper and lower portions. So maybe you want the quick dots just to get a sense of your data, but then you want to be able to check what the actual values are. You can do it all in the same plot, which is really, really cool. And it's actually displayed, the variable names kind of down the middle here, which is really nice. It makes it look a little bit cleaner. And I think, okay, so this one I'll do. So obviously in these previous examples, let me go back up here a little bit. So it's just listing the columns or the variables based on the order they are in the data frame. So whatever order they happen to be in your original data is how they're going to be displayed in your final plot. But you can actually tell core plot to sort of cluster your data and kind of create these groups of variables that are kind of more highly correlated with each other. And there are different methods supported. So we have like k-means, hierarchical, or other methods I'm sure as well. So we can do that with this order argument in core plot. So I'll switch back here to R and say clustering our data. So core plot on mtcars, oops, core. Why don't we do like the kind of mixed? So we'll do lower number, I think it was, and upper circle, and then border equals, and we'll do hclust, which is like a hierarchical clustering. Ooh, that did not work. Let me check this. Lower number, upper circle. Okay, maybe it doesn't work with clustering, or maybe I don't know.
When you mix the two, the function is actually called core plot.mixed.
Oh, I missed that. Absolutely correct. Thank you very much. Going a little too quickly there, but so yeah. So I'm actually, you know what? I'm gonna redo this. Not as mixed because I think it's easier to see the groups in that case. So we'll just do empty cars core and order equals h plus. There you go. So now you can see like it's changed the order of our data. So instead of MPG at the top, we now have carb. And you can clearly see like different groups, mainly these two kind of large groups that exist within our data, which really helps you kind of pick out trends or similar variables in the data that you're working with. And then I think the final thing, yeah, so we can also use CorePlot to help us even more identify these groups with this add rectangle argument. So here you can see we're telling it to make 2 rectangles, and it's drawn these nice boxes around our 2 most obvious groups. So I'll switch over back to R here and just say adding rectangles. So CorePlot, again, oops, on our empty cars core data, we'll do order equals h plus and add rect, and we'll do 2. And you can see our plot is the same, except we've now added these boxes around to help us highlight the parts of our data that are highly correlated. And it gets even better because we can actually specify more rectangles to be added, and they can maybe help us identify kind of smaller or like harder to identify groups within our data. So again, if I swap back really quick and do, oops, I'm just going to copy and paste from before. So adding more rectangles, and we'll change this to 3. And you can see now it's changed. Instead of 1 larger rectangle down here at the bottom right, it's created kind of 2 smaller ones. So you can see this kind of little group of Q, sec, and VS, whatever those mean, are like super highly correlated with each other. So that's pretty cool. Maybe you want to, look more into that and what those are. I'm sure there's an explanation of what these empty cars variables are, but I don't know off the top of my head. So yeah, I think that's pretty much everything. I apologize, it went a little quick there at the end, but I guess we were at least able to kind of go through everything at least briefly. So again, all of the material is going to be available online. If you wanted to revisit it in your own time, you can do so, and you can try the challenges. The Slack channel, I think, will still be open for a little while, so people can still ask questions. So yeah, hopefully you guys, just like this little cute little cartoon here, were maybe intimidated by R or something, and now see that it's actually not too bad. And maybe you'll be encouraged to use it in your daily work. I know I do, and it's great most of the time. But yeah, we just want to take a moment to say thank you guys for coming out. I hope you've learned something today. And again, if you have more questions, I think I can at least stick around for a few minutes to maybe address anything you guys have. Any other comments or anything are certainly welcome. Yeah, thank you guys again. I hope this has been helpful.
And before everyone leaves, I just want to make sure that you saw, oh, wow, Jasmine is like reading my mind. Jasmine, are you here?
Jasmine, what's happening?
No, that's crazy. Wow, okay, so she's reading my mind, and I just wanted to plug the post-workshop feedback that Jasmine just posted in the workshop channel. So please make sure you take some time either today or tomorrow to fill that out. We always welcome feedback, and you can, at least for me, feel free to contact me. This website has all my contact information on Twitter, Facebook. Well, no, my Facebook is not. My Twitter is probably the best place to go, and I think my email is also connected on the website as well. So feel free to reach out to me. And I think, Travis, what's the best way to reach out to you?
I'm not sure if my email is in there, but definitely on the Vancouver Datajam Slack, I should be available for messaging, I assume. So you can always message me there. I'm also part of the UBC, our study group, for anyone who's out that way. So you can contact me through those channels as well. We have a GitHub page, I think is probably the best way to find the info. But yeah, Slack or maybe the UBC, our study group GitHub, which I could post in the chat as well if people are interested. But yeah, those would be best, I think. So yeah, thank you guys again. Hope it was good. Hope it was helpful.
Thanks, guys.
That was really good.
Yeah, it was well organized, and it's amazing how you always can learn something new every time someone else is showing you their code. So
every time I do this, I learn something.
yeah.